Okay, so we stalled out right here. We were finding all these different logarithms. And we're here on letter E. So we want 3/5 ln, here, 3/5 ln e to the negative 20. Okay, now remember, because of the power property, I can bring that negative 20 down in front. So I can make it times negative 20. I suppose I should put that in parentheses. Times negative 20 times the ln of e. But the ln of e, once you do that, the ln of e is just 1, right? So it's gone, right? So it gives you 3/5 times negative 20, which would be negative 60 over 5, so negative 12. You can use a calculator too if you want. All right. I suppose I should have crossed those off all along because the ln of e is 1. That's, why it goes away. Okay, and that's what we defined right here. And honestly, these two are a little bit out of order, but that's okay. Right, so the log base e of e, that's 1, right? All right, so now let's remind ourselves just for a second. If I was going to rewrite this a little bit, negative 20 in a power would really mean 1 over, remember? From chapter 4. So we're going to use that right here. So this is ln of e, the natural log of 1 over e to the third. Okay, but that's really the natural log of e to the negative 3, remember? Because powers that are negative make fractions. Well, that's really, you can bring the power down in front, negative 3 times ln of e, but the ln of e goes away. So you're left with negative 3. Okay, so that means that's a reminder of something we already learned in chapter 5.2. But I'll just remind her, that's the way this section goes. Reminder, the log of a fraction, like 1 over something. I'll just put fraction. How about that? If I could spell it. Fraction, there we go, is equal to a negative. Negative. All right, now what about these ones for g and h? Well, they don't have fractions. Well, h does, but g doesn't. But we've seen roots before. We learned about them in an earlier chapter, actually earlier section. So do you remember what it was? Fractions, right? Okay, so let me remind you. So this is the ln of the e to the third to the fifth root. Okay, so remember we learned that in section 4.3 that this is e to the 3 over 5. The root part, the root index is what that's called. It's called an index, becomes the denominator. Well, we all know that this is going to be 3/5, right? Times the ln of e, which is just 3/5. Right? Because if I bring my power down in front, right, and multiply it, then this part right here goes away because it's 1. And 3/5 times 1 is just 3/5. So there's your answer, 3/5. Okay, so let's remind ourselves. Oopsie. Log of a root is equal to a fraction. Okay? And remember also, the roots don't always manifest themselves like roots. I mean, if I put the root symbol in there, it's kind of obvious. But sometimes it's just a smaller number, right? Because roots make things smaller, right? So let me give you an example. If you had, oh, I don't know, the log base 100 of 10, that's equal to a half because you need to take 100 to some power and get you a smaller number. So really this is a square root, right? Because the square root of 100 is 10. And that's why it's coming out that. That's just a little review of what we already learned. We learned this, by the way, in section 5.2. And we also learned about roots themselves in 4.2, I believe. Nope. Yeah, 5.2 and 4.2. We learned about both of those. And same with this. We learned about this one for sure in 5.2. Okay. All right, now the last but not least, we have doubles. We've got a fraction, so it's going to be negative, and we have a root, so it's going to be a fraction. So let's see here. The ln of 1 over, let's see, what root was it? The e squared to the 7th, or 1/7, I should say. Yep, okay. So this is equal to the ln of e to the negative, because you got the 1 over, 2 because 2 is the power, 7 because 7 is the root. And that means that our answer is going to be negative 2 over 7 times the ln of e. And then the ln of e goes away because it's just 1. So that means it's negative 2 over 7. And there's your final result. Done with that. Oh, let me just throw over here. Cool. All right, we're done with that. Now let's see what we got. Ooh, some solving. Okay, so let's see here. We have 2 times e to the t plus 4 equals 76. Now you want to solve this, which means you want to end up with an equation that is t equals stuff, right? Okay, so if we're going to do that, we're going to need to do a couple things. Now you notice where your variable is. It's in the exponent. See it up there? There is one way and one way only to get a variable out of an exponent. Logarithm. Did you say logarithm? I hope you did, because you should. It's a logarithm. Now the kicker is you can't take the log right yet. You can only take the logarithm when the thing that's raised to the power is by itself. In other words, you need to get rid of this coefficient of 2. So I'm going to divide both sides by 2. Okay, so over here, the 2's are gone. There we go. You're left with e to the t plus 4 is equal to 38. Oops, 38. All right, still want to get that variable. Remember, e is not a variable. That's sometimes students get confused because they think, oh, it's e. I should be solving for e. No, 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 no. E is not a variable. E is 2.718 and change, right? According to Wolfram Alpha, this is what it is, right? So you don't need to solve for it. We know what it is. You know, John Napier and Bernard Euler found it. But what we do need to do solve for is t. But t is in the exponent. See that? So we need to get it out of the exponent. Now, there is only one way to get it out of the exponent, and that's the logarithm. Now, you could take any logarithm you wanted. You could take logarithm-based apple pie for all I care, right? But the problem is that there's one logarithm that'd be really smart to take. One of the two, for example, that your calculator does. So if you're going to do this, it'd probably be smart to pick either log or ln. But because the base of our exponent is e, see that? ln is the inverse function of that. ln and e to the x are inverses. That's why they're on the same button together. So the smartest move would be to take the ln of both sides. Take the ln of this side and take the ln, natural log, of this side. Then I can bring my t plus 4 down in front. So it's really t plus 4 times the ln of e is equal to the ln of 38, natural log of 38. But the ln of e, because you picked it that way, is gone, right? Because the ln of e, they're inverse functions of each other. They completely undo each other and make 1. So you're left with t plus 4 is equal to the ln of 38, natural log of 38. Well, the natural log of 38 is just some button with my calculator. So clear. ln 38, enter. 3.6376. So 3.6376. That's what t plus 4 is equal to. All right, So if I want to solve this for t, I just need to subtract 4, but from both sides. So t is about, and then let's see, I'll go back to my calculator here. Subtract 4. Negative 0.3624. Oops, I did that backwards. 3624. And we're done. Diggity done. Cool, huh? All right, now we're done with that one. I think we've got room for B on this video. We might not be able to do C. So let's do B together. Now, B is very different from A and C. A and C both have the variables in the exponent. See that? So both of these problems are going to require you to take a logarithm. B is a different story. Actually, you know what? Let's do C first, and then in the next video I'll do B, because C is basically the same thing we just did. So let's do it. So you have e to the 2x minus 4 times e to the 4x equals 89. Oops. There we go. Okay, so now remember the properties of exponents, right? And e is no different than any other exponent. What you want to do is you want to add these. So you want to take 2x minus 4 plus 4x. And this is a little bit preemptive, but in chapter 6.1, you're going to say, well, that means we got to combine terms. I agree with you. Let's combine the terms. So this is e to the 6x minus 4, because like terms are 2x and 4x. Okay, now at this point, we're very similar to what we had in this problem above. We had e to the t something is equal to a number, and you now have e to the x something is equal to a number. So you want to get x by itself, you're going to have to take the ln of both sides. And again, you don't have to do the ln, but it's a lot easier if you do, right? Because the ln is the inverse function of that e to the. So it's going to mean that you're going to have 6x minus 4 ln of e equals the ln of 89. But the ln of e, this is why you picked ln, is gone. They're inverses, so it makes 1. So you're left with 6x minus 4 equals the ln of 89. Oops. Sorry about that. All right, so now the ln of 89, it's just a number, right? So it's 6x minus 4 is about equal to, hold on, where is that? Nope. I'm trying to find the squiggly equals. There it is. All right, ln of 89, let me grab a calculator. ln 89, enter, is 4.4886. So now all we got to do is add 4 and divide by 6 and we're done, right? So add 4 to both sides. So you're going to get 6x is equal, well, squiggly equals, to 8.4886, right? So we added 4. Now we're going to divide by 6, but we're going to do it to both sides, right? So divide by 6. Divide by 6, and we're going to have x is about, well, let's see here, hold on, I've got my calculator. So I wanted to add 4 to this. That got me the 8.4886. I'm going to divide by 6, and I get 1.415. There it is. Now hopefully you see how very, very, very similar these two problems for A and C were. They both involved the variable in the exponent, which meant you had to do some simplifying first, try to get e to the something by itself, and then you take the log of both sides and solve from there. This one actually for A involved a little bit less work because it didn't have so many e's in it. All right, I'll see you back here for part B.